Hey everyone, as John mentioned, I am the speaker getter. I don't really know what the actual title is. But by the way, if you happen to have a topic that you want to hear about, but maybe don't know about it or don't want to present about it, that's fine. Feel free to bring it my way. Maybe you want to hear about cube chains or something different. That's fine. Bring it to me. I'll find a speaker for it, and we'll get someone in here who can start talking on whatever topic you're interested in. So just let us know. Without further ado, I'm going to let Naki Rosa, is that correct? Okay. I've been talking to you a lot, but I've never actually tried to. Anyway, so Naki's with Phil 66. This is our first time to actually have Phil 66 interns in this year in Bug. So this is a pretty exciting event for us. Normally we bring ConocoPhillips, but we wanted to share the love. And Naki's here to talk about blockchain, of course. He's actually from Texas A&M. Don't hold that against him, it's okay. But he studies computer engineering there, so we're glad to have him. And he actually mentioned that in his free time he develops games, as I understand, which I wish he could have made it here last month to a presentation on Unity. He could have had some good talks then. But without further ado, I'm going to let Naki take the floor and start his presentation.
All right, see if that's going to be hitting me in the face if I stand over there. So I'll stand over here. Hello guys, as he said, my name is Naki Rosa, and I'm going to be presenting over blockchain. So you got to help me out a little bit with the introduction, but I'm going to quickly go a little more in depth on me so you know who I am. So I attend Texas A&M University, set to grad in December 2017, and I'm in computer engineering under the computer science track. So in school, I'm involved in the Student Engineers Council. So if any of you guys have ever gone recruited at A&M, our organization essentially puts that together because it's student run. It's 100% students put it together and see it from the beginning to the end. So my responsibilities during my tenure as system administrator chair was essentially being the tech guy. Anything that needed to be developed, if there was any websites needed to be made, I was the one that did that. So a couple of things that I did is I transitioned my company's websites to Amazon Web Services. So that was a really big deal, moving to the cloud in that aspect. And I'm currently developing a mobile application for the career fair. So it's going to be used by roughly 10,000 engineering students that attend our career fair. So very happy to be writing an application that actually goes through and impacts a large majority of the engineering school. Did I have something else in here? I guess also personal projects on here. He mentioned that I like to make games. It's whenever I have time, I'll go and try to code games, see if I can make something fun and whatnot. Other projects that I've had is I've made a hat that senses the vibrations in the area and points to the direction that sound's coming from, and its purpose is to help hearing impaired people be able to detect where sounds are coming from in case they're walking down the street. You need to know that it's a car honking at you or something. And LiDAR car, I brought it last time, but essentially meant to map out its environment using LiDAR technology, which if you guys don't know, it just essentially shoots light in a direction and then waits for it to come back, and that's how it maps out its environment. It's very efficient. It's very cutting edge, and I really enjoy it. So now that I've talked a little bit about myself and who I am, I want to go over the two most known cases of blockchain. So Bitcoin, I feel like that's probably why people are interested most in the blockchain. People have a passing knowledge of the blockchain because they've heard of Bitcoin. So essentially, Bitcoin is just a cryptocurrency used to do online transactions. I'll go more in depth into that later. And the other big use case is, the no user case application is Ethereum. So essentially, it's a open software platform that developers can build and deploy applications on. The reason why I'm mentioning it is so that I can go to what I like to call the why do we care slide. Essentially, why has blockchain technology been so prevalent over the past couple of years? And if you guys know the charts of how the stocks and the prices for Bitcoin and Ethereum rose, you're kicking yourself in the butt for not investing early, because that's in a year span how much the value of blockchain and Bitcoin has increased. So you can see Bitcoin went from 500 to almost 3,000, and Ethereum went from $7 to roughly $400. So this technology is being explored very deeply just because it has a high, there's a high interest in getting that technology to be able to be applied in large areas. And also, I guess heads up on there, people might have noticed all the slides are white. I like it being nice and simple. So if that if it bugs you, the fact that everything's white, I apologize, but I enjoy it. So just for me. So let's get down to the nitty gritty. What is a blockchain? So a blockchain is a digital and distributed ledger that's essentially of transactions across a peer-to-peer network, or nodes, essentially in the network. So blockchain is essentially to a ledger what a block is to a row. So you have a ledger, think of this as your blockchain, and each of the rows is a block in the blockchain. And each of those blocks, once they get added onto the blockchain, it essentially is a link. So you got to add it to the end of it, and the ledger essentially keeps the transactions that have happened since the beginning. And each of those pieces of blocks can execute code. That's one of the big applications for the blockchain, is the fact that you can make transactions that have them automatically execute code once they're processed. I'm going to bring the wire over here because it's all the way across. So Bitcoin. Bitcoin is the most common application, most well-known application of the blockchain, so I want to use it for a couple of my examples. But, just want to bring up the fact that essentially what the blockchain does with the blocks is you can put anything on there. You can say person 1 has 6 Bitcoins, and that would represent that a peer in the network or a person using the blockchain has 6 Bitcoins. But it can also be anything else. It can be something as abstract as watts of cash. You can say, I have 6 watts of cash. Something as abstract as barrels of oil, ConocoPhillips and Phillips 66 might be a little more applicable. You can even have contracts added into the blockchain for each of the blocks. But essentially, I'm gonna just be referencing Bitcoin for the examples I'm gonna use, just because most people are more familiar with Bitcoin than the other users, in my opinion. So, what makes the ledger distributed? So in a peer-to-peer network, here we have 2 peers, 2 nodes in the network. If there's a transaction going to happen, such as node 1 sends a Bitcoin to node 2, essentially it gets recorded in the ledger, but the ledger isn't in one singular location. It's distributed and decentralized. So each node in the network has its own individual copy of the ledger, and that's essentially what makes it so stable in the long run, which I'll go over in a second. But whenever you have a larger network of nodes, even if the other nodes in the network didn't participate in the transaction, they would still get a copy of that transaction that happened, which is the block. So that's how the blockchain keeps getting added. Every node in the network has a full copy of the blockchain stored locally. So now I'm going to talk about what makes a blockchain so secure. So you have another, smaller network for people in the network, for nodes in the network. And there's a transaction that's going to be essentially analyzed by the nodes in the network. So whenever you have a node 4 send a Bitcoin to node 2, the transaction that the other nodes have to approve of is 1 Bitcoin sent from peer 4 to peer 2. So all the nodes in the network have the option of verifying the transaction, seeing if it is a valid transaction, and then if they approve it, they can add it to their own personal blockchain. So that's how the blockchain, remains in sync, regardless of what happens in the network. All the nodes in the network have that same copy. So same thing, you can guess what's going to happen there. They're going to try to see if that transaction is a valid transaction. It gets approved, and then they add it to their own personal ledger. So whenever there's a bad transaction, say for whatever reason somebody tries to stake a transaction that didn't exist prior to the blockchain, such as 1 Bitcoin added to peer 2, say peer 2 has been compromised. Essentially, once the other peers in the network realize that there's something going on, they can essentially reject that transaction and then not add it to their own personal blockchain, essentially making that transaction useless, because since the whole nature of the blockchain is that it's distributed and shared between everybody, this is out of sync, so that's not a valid transaction. They all know that at that point. So I'm going to go a little bit more depth for that. I had originally created this presentation for a higher level group, but I feel like I can go a little bit lower with you guys. So this is essentially going to go over, I'm essentially going to go over the way that verification happens. Again, now that you guys get a broad view of it. So essentially, in the Bitcoin network, you have something called miners. I'm sure you guys have all heard the term, maybe some of you guys have considered being miners. But essentially what miners do is their job is to verify the transactions that happen in the blockchain. So I mentioned earlier in the previous slide, every node in that network was a miner, essentially. They could all verify whether or not that transaction was valid. So whenever there's a transaction that they're trying to verify, they're essentially competing with each other. Each of the miner nodes competes with one another to try to figure out what the transaction is. So I'm gonna, nice little animation right there. So essentially what just happened was, there was a transaction. They needed to figure out if the block fit in the network. And the way that they do that is they try to solve essentially an algorithm. There's an algorithm that whenever you add a new block to the blockchain, it needs to be a hash of the previous one, as well as have a timestamp. So whenever you're trying to verify it, essentially the way that you solve the hash is you guess. You just continue guessing until you eventually come up with a block that actually does fit that algorithm. So now that this miner node right there has been able to find a solution to that algorithm, it gets a little prize. In Bitcoin, the prize that it gets is a little bit of Bitcoin. So that's where the incentive for mining accurate blocks comes from. Essentially, all the miner nodes are competing to get the prize at the end of the algorithm. And then once the miner node has found that solution, it passes it along to every node in the network. They all add it to their own personal blockchain, and then the process starts all over again. So if you guys have heard, there's a lot of like farms in China where they just have hundreds of computers that are essentially running these algorithms, trying to figure out a solution, because each Bitcoin is roughly, if I remember correctly, about 420 points, and they hand them out in like sets of 30s every time you solve something. So if you can solve a lot of these puzzles, you're making a good amount of money. So it's really a competition for you to get the largest amount of money, as well as doing it in the fastest time. And like I mentioned before, being a miner node is optional. Every node in the network can be a miner node. It's just, a lot of people just are satisfied with not mining and just actually partaking in the whole process. But since Bitcoin is such a high commodity at this point, there's a high value associated with it. A lot of people are trying to compete for that resource. So there's a lot of people that don't even participate in any blockchain transactions. Their one and only goal is to grab Bitcoins and wait for their value to grow and then sell them off. So I'm going to talk over a little bit more about the security aspect of it. So essentially, for you to be able to compromise the blockchain, you're going to be able to compromise a majority of the nodes in the blockchain. So you'll notice right there, even though a couple nodes have been compromised, the majority of the blockchain is still intact. The fact that they have to come to a consensus before adding the transaction to their own blockchain essentially means that if all the good nodes agree, then these ones that can't break the blockchain. The only time that the blockchain can be broken is whenever a majority of the nodes have been able to be in compromise. So as you guys can imagine, essentially to be able to compromise so many nodes, so many different computers, so many different users that are generally across countries is very computationally expensive. You gotta do it really quickly, and in most cases there's a window of time, because at least I know Bitcoin and Ethereum blockchains check themselves every 10 minutes. So you're gonna compromise a majority of the nodes in the network within 10 minutes, as well as compromise their own individual ledgers. So I had a little nice animation for that. So essentially the reason why I showed it like this is because it's a very slow process. If you want to compromise a node, a block in the blockchain, since it's a hash of the previous one, you can essentially compromise every single block that led up to that one block being created. So not only do you have to compromise a majority of the nodes in like a very large network, but you also have to go through and compromise their individual ledgers one by one, pretty much, all under a certain amount of time. So that's one of the big reasons why people don't necessarily go and try to break the blockchain, because for you to actually successfully do it, you have to invest a lot of computational power, have an insane amount of time to work, essentially, whenever in reality, people just don't have that amount of money. They're hacking it to get money out of it, and there's just no benefit from them doing it. So there are 3 different types of blockchains. So there's public blockchains, consortium blockchains, and fully private blockchains. And essentially what that means is who has the right to verify transactions. In public blockchains, everybody has the option to go and verify the transactions that happen in the blockchain. With a consortium blockchain, essentially, say you have like Conoco and Phillips are in a deal or something with a couple other energy companies, they essentially allow those companies or those peers in the network to be able to be miners if they want to. If not, then the other people don't even get an option. They can just be a part of it, but they can't go and verify transactions. And fully private is just when one entity controls all of the nodes that are doing the verifying in that network. So on that, I'm not done yet, but I want to address any questions. I don't want to lose any people in the explanation of blockchain. So is there any part of that whole thing that people have a question with currently?
Outside of currency, why would you want a private blockchain?
Mostly just for security purposes, especially is one of the downsides I'm going to talk about in the coming slides. But essentially, there's a lot of regulations sometimes happen. You don't want to be able to, if you're in a corporate setting, you don't want to give random people the chance to be both a node and be able to verify network transactions, because by its definition, it could be a smaller network. It could be easier to corrupt the network. So it's just one of those things. The people like controlling which people can do the verification, and sometimes a company wouldn't want to have other people or the networks in the other nodes in the network be able to have that power.
Couldn't that be for supply chain optimization too?
Yeah, absolutely. So with that on, I'm gonna move on. So just to recap a little bit, the big thing that makes it so stable is the fact that it's peer-to-peer, and then with this comparatively it could have been client server. It's a lot easier to just target the servers and then have that crash. Essentially, I'm sure a lot of people have here used peer-to-peer network, some type of torrent and whatnot. But essentially, once you take, no, you guys would never do that. Yeah, participate in that stuff. Anyways, so you guys don't know because you've never done it. If a couple of the nodes that compromise, say that you have something illegal going on and a lot of the nodes are there, and you cut those off, the network's still running by itself. They just lost a couple of nodes in the network. It wasn't relying on any one specific source. And that's one of the big things about the blockchain. It's decentralized. For you to take it down, you're gonna go after a lot of things, not just the one thing in the center. And here's a lot of the other applications that can be done for blockchain, which I'm gonna go over more in depth in a couple minutes. But you have currency, which is currently the most popular one, but smart contracts are currently, in my opinion, what the best possible corporate setting implementation is going to be. So I know everybody wants to learn about Bitcoin. So for my presentation that I'm basing this off of, we actually didn't study Bitcoin that much. So some of you guys that are actually involved in Bitcoin transactions might know more than me, but I'm gonna do my best to explain that. So essentially, this is a very simplified diagram of what I just did. So people request a transaction. The transaction is broadcast to the network. You verify the transaction using miners, and then once it gets added to the blockchain, it gets sent out to every block in the blockchain, and it syncs it up. Very similar to what I just went over, but this is just a specific application of how the Bitcoin works. So why Bitcoin is successful, as I mentioned earlier, Bitcoin has the potential of being decentralized. A lot of people don't like having their money regulated. There's no middleman in the transaction, so whenever you are dealing with a bank or you're doing transactions or doing any sort of financial dealings, you generally have somebody in the middle that takes a fee from both sides and ensures that the transactions are happening. Bitcoin, since it can check itself, you don't need to have a middleman to do those to verify transactions by itself. So automatically, it's already eliminating the middleman. That's one of the big reasons why people are so invested in Bitcoin, outside of being able to do sketchy things, is the fact they can cut costs in the middle, which is very big. And again, it's unregulated. That's one of the reasons why Bitcoin is so successful in today's world. And also, people buy a lot of Bitcoin because its value keeps increasing, because this new technology is getting more and more realized every day. People are finding more legitimate applications for it as it grows. So investment in Bitcoin keeps increasing, and people keep just buying coins, hoping that their value is going to increase. When it first started, Bitcoin was being used to buy pizzas. You'd use like 400 Bitcoins to buy one slice of pizza, essentially. And now 40 Bitcoins are worth an insane amount of money. So, that's just if people had realized how much it would have grown at that time, they would have invested early, kept it, and just watched it grow. And that's what a lot of people are doing nowadays. I'll talk about Ethereum. Okay, so Ethereum is a lot cooler. So I guess I show off. I know people have heard of Bitcoin, but who here has heard of Ethereum? I know you. Where's Bradley? I know you have. Okay, so Ethereum essentially is it's very, very on the rise, but it's a decentralized platform that allows people to run smart contracts or build and develop their applications. So it's open source. If you guys invested in it, you know that a couple of days ago it got hacked. It's very early on in its development. The blockchain technology in it is secure, but a lot of these technologies are still increasing. So essentially, instead of having the Bitcoin that's being traded, Ether is its currencies per se. Very similar to, I guess, if I had an analogy to make, back before we had, paper money and whatnot, commodities and, food, services were the trading. That's kind of how I see the Ether. People essentially try to mine Ether because it allows them to use blockchain resources. So it's another way that the blockchain is being applied, and the competition is going. People try to mine the Ether because they want their application to have certain accesses to the blockchain. And gas is just a term that I came into contact a couple hours ago. Essentially, what gas is, it's a measure of how computationally expensive the program is, and it's used to essentially base how much resources that program is going to absorb from the blockchain. So smart contracts. Smart contracts, in my opinion, are the best potential application for the blockchain technology in the corporate setting. So essentially, with contracts, instead of having bitcoins that are being sent through, you're sending contracts that automatically perform the actions that they're predefined to do when certain conditions are met. So say you want to make a transaction that says, I want to send 3 payments to this person at 12, 1 p.m. and 2 p.m. Making that transaction makes it so that once you send it, you don't really have to deal with it. So that's what smart contracts essentially are in a nutshell. And potential applications of that is for crowdfunding. So essentially, if you're trying to fund somebody and whatnot, you want to make sure that the money that you're investing in them actually gets used for the purpose that you want it to. And I know that's a big issue with a lot of charity companies and whatnot. You don't know where your money is going to end up. Blockchain aims to fix issues like that, because if you program it to actually send money to a specific resource, and if they try to use it for something else, then the money gets sent back to you. So that's one of those contract things. You make a contract with a company, it will automatically enforce the regulations of that contract without having to have a lawyer in the middle to say, no, you can't do that. Voting, one of the big issues with voting is, I guess, not in my opinion, but there's a big controversy around, whether voting can be hacked, whether voting can, be compromised. With the whole aspect of blockchain, voting is one of the potential applications that people are kind of hoping gets applied, but might not, just because government regulations are generally in check. But essentially, it would make it to where voting is transparent. You can view how people are voting, not necessarily who's voting, but how they're voting as it's happening, and making sure that those votes can't be transmuted or deleted or manipulated, because the blockchain, as I mentioned earlier, is a very secure building block for that. So that wouldn't necessarily be very corruptible. And then property, I mentioned earlier, contracts, you can lease out your house to somebody, and then if you can approve that they did something in the contract that they weren't supposed to, then the money would automatically get sent back to you in that contract that you made. And then bill of lading, which is a bit more specific application of the smart contract. But it's we like having user cases, and that's one of the use cases that exist that we were investigating. So essentially, a bill of lading is a legal document between shippers and carriers that essentially describes what item are we transporting here, what the item is, what its properties are, and it just travels with the goods on paper, and people essentially sign onto it as it's going through the process. So blockchain would fix this. I think I want to say thank you to one of my teammates for having this video. But essentially, you have the contract on there, it comes up, people start signing it, and you can see live how they're signing it. So it's going there. It's going a little bit slow this time. But essentially, as it's moving across the whole process, people can track it and not necessarily have to do it on paper. And it's just one of those contracts that once something arrives to the dock, or you have a shipment arrive, it would automatically execute some sort of code that prints out a sheet of paper for the person that receives it, like, hey, you gotta sign this, or hey, make sure that you send this over here. And then if they don't do it, then you could program the blockchain to send you a notification when that doesn't happen. So again, I wanted to use this as a use case. I can't say that company's name, but they opened up trials for this in May 2017, and we're still waiting on it, but it has the potential to essentially get a solution to not having that many people working from the organization, having their time consumed, letting them do something else, getting rid of that stack of paper that's associated with those transactions, and then trying to reduce the number of people that are involved in the middle. It's faster, it's more accurate, and it has increased privacy and transparency. So, I might just go over some of the pros and cons. Some people in this room might be very well versed with this slide. That's this slide. No, so the pros of it. It's a very secure framework, as I mentioned earlier. It's very hard to change it. It's immutable, and that's essentially the same concept. It has integrity, transparency. I didn't talk about this much, but in public blockchains such as Bitcoin, since everybody has a copy of the blockchain, they can see what's going on. So it's really hard to try to, whenever you have like a public network, it's really hard for people to try to pull something on other people just because it's so transparent. You can see all the transactions that are happening, and you have a copy of that blockchain. So it's economic simplification. Again, like I said, eliminating the jobs of middlemen everywhere. The fact that it can verify itself is already a huge expense for a lot of companies. So already there, it's just simplifying one step of the process. Couple of the cons I want to talk about. So the blockchain has a lot of negative connotations, essentially. Mostly because of the Bitcoin application that it has. People hear Bitcoin, they're like, oh, no, that's a sketchy application. We want to implement it. And just in general, it would require a lot of changes in any infrastructure of the companies that are trying to implement the blockchain. So that's one of the biggest hurdles that we're facing, is that it's a disruptive technology. A lot of companies would have to change the way that they go about implementing a lot of their infrastructure to actually accommodate the blockchain. Integration concerns, again, you have processes that can't really be gotten rid of, and you want to integrate into other processes. That can be really hard. That can cost people's times to actually get it going. Once it gets going, it'd be great, but actually being able to convince people to start that integration would be really difficult. Regulations I mentioned earlier with the voting example, it'd be a great application for voting. Already people are saying that it should be implemented, or there should be a test run with it. But essentially, it's one of those things that government would never trust, like a developing technology that hasn't been fully realized to be implemented. So it's one of those things that it got conceptualized in 2008, and they got applied in like the following years. So it's really early. It's only been about 7 years with very little people actually knowing fully what it is capable of. So regulations is going to continue being a huge hindrance in the new technology. Early adoption, that shouldn't be on there. Uncertainty. We don't know what's going to happen with it. As I mentioned earlier, there's a lot of, if I can go back to a couple slides. Anyway, so if you guys remember the stock plan, the stock shares on it, you'll notice that like it just changes really rapidly. It can go really high and it can crash and it can go up again. Whenever Ethereum got hacked the other day, prices plummeted and then rose again, and they plummeted again a couple of days ago. It's very uncertain where the new technology is heading, but the general trend is that it's been growing, but people don't know when it's going to stop growing, when it's going to peak out, or they don't know like the small term. People that are investing in this new technology don't necessarily expect their stock to always stay positive. It'll go negative, and it'll go positive again. Then it's just such wild variations that it's just a very uncertain technology to apply anywhere. And credits. So does anybody have any questions about the blockchain now that I've gone through everything, or like its applications or how it functions?
So as you add more nodes to the peer-to-peer network, how do you handle like the increase in network traffic?
So essentially,
more and more time voting.
So I essentially mentioned this earlier. So I said there's like a 10-minute period where like the blockchain checks itself. That's essentially the time that it's taking for the miners to verify transactions. So all the transactions get logged into a block, and then that gets added to the ledger, and the miners are verifying a set of transactions in that block. So the reason why I'm mentioning this is because the more people there are in the network, the longer it takes for miners to continually verify the blocks that are coming up. So it's just one of those things that to get the pros of the blockchain being so secure, being highly immutable, you kind of have to sacrifice a couple of the speed aspects of it, because it takes by its definition, it's hard to change, so it takes a while to change it. And the more nodes that get added, the higher that overhead time grows. Mm-hmm.
When someone wants to add a legitimate transaction to the ledger, how does that first transaction essentially get propagated without the others thinking that it's fraud?
So the other nodes that are essentially receiving the transaction, the block, they pretty much trust the miner nodes to do their job. They're not mining, they're not verifying the transactions. Once they receive that, they add it to their own ledger. As I mentioned earlier, with the cases of Bitcoin and Ethereum, it's not really a problem that people would try to pass them, wrong blocks, because the profit in the blockchain is actually getting valid blocks out there, because the first person that can find a good block makes money, and the people that don't make any money, and then they can kick them off if they're starting to pass out bad blocks. So they might, have a short-term gain, but in the long run, it's not profitable for people to actually go through and pass bad blocks to the people in the peer-to-peer network for that reason.
What are the primary ways to mitigate theft of cryptocurrency? Because in the case of Ethereum, so based on your example, if you can compromise enough nodes to create a quorum to promote the bad entry on the blockchain, I guess at that point the theft of the currency is pretty much unrecoverable unless you roll back the entire blockchain, right? Which obviously would effectively screw over everybody else that had transactions in the end. So how do you mitigate that?
So essentially the bigger problem with the blockchain technology is not necessarily in the blockchain technology, it's the individual end users. So as you mentioned earlier, so the issue that I mentioned with Ethereum, essentially, you guys are gonna get a hoot out of this. They declared a function for a new functionality. They wanted to have multiple people be able to have different wallets, which essentially is what it means to have Ethereum. So essentially what they forgot to do is they forgot to declare the function private. So I'm not kidding, that's actually what happened. They forgot to declare the function private. So whenever you go to the GitHub commits and you actually look at the changes, it looks like the fix pretty much somebody just added, it was called multi-party wallets, they just added private to it and then it kind of fixed it. So it's just one of those issues that the blockchain technology is not necessarily at fault in that scenario. It's the fact that it's a developing technology, people are still getting the software that interacts with technology out, and that's where the weak links are.
And I guess security around the computer system.
Essentially, yeah. So it's just one of those things that, funny, I'm gonna go a little bit of a tangent on here. Whenever that happened, people were stealing money out of that specific wallet, but they weren't stealing money out of the blockchain in general, because for the network's concerned, that block was doing, that node was doing what it was supposed to be doing. The node was compromised, but that's not necessarily the blockchain's issue because the blockchain's still functioning. So what happened was a lot of white hat hackers stole all the money out of the nodes that had that vulnerability. So like white hat hackers had like $30 million just stored in their wallets, just holding it so that they wouldn't get compromised. Once the issue got fixed, they're giving the money back. So that's how they fix that. So it's a big community of people working together that legitimately are trying very hard to make the blockchain work without those little bugs, because they profit if there's no bugs, because that means the stock keeps going up. I hope that answered your question.
Yeah.
So is there every currency added into the system for Bitcoin?
So this is actually one of the long-term issues with Bitcoin. So there's a set amount of money a set amount of Bitcoins that can ever be released, and people do get money out of the blockchain every once in a while, and that's what mining is for. That's where that money is coming from. So they have a safe, a huge just safe of Bitcoins that are haven't been mined, that nobody's using. So when people mine it, they're actually grabbing those coins and adding them to the whole circuit. But if you read up on blockchain at all, you'll notice that every year or so, as time passes, the less coins that are being mined by the miners, because the repository